For today's question, we are going to consider a piecewise function fx defined as x squared sine 1 over x when x not equal to 0 and f0 is equal to 0. There are three statements right here. The statement 1 says that the limit of derivative x when x goes to 0 does not exist. And for the second one, the limit of fx minus f0 over x when x goes to 0 is equal to 0. And number 3, f prime 0 exists and f prime is not continuous at x equals to 0. Out of the three statements, which of them is correct? What do you think? So we look at it one by one. For number 1, we have to find out what is the f prime x. According to the definition, f prime x will be equal to x squared. Then sine, differentiate sine, we have cosine. After that, differentiate 1 over x, we have negative 1 over x squared. Plus, we write sine 1 over x and differentiate 2x. Differentiate x squared, we have 2x. And for this will be equal to negative cosine 1 over x. And for this, it is 2x sine 1 over x. Note that the limit of 2x sine 1 over x when x goes to 0, it is equal to 0 because of the squeeze theorem. X sine 1 over x is always in between negative modulus x and modulus x. Using squeeze theorem, we know that this is going to 0. However, for the cosine 1 over x, when x goes to 0, it does not exist. So f prime is the sum of these two functions where the limit of one goes to 0 and the other one does not exist. What happened to the overall? From the theorem, if both limit fx and gx go to a-axis, then the limit of fx plus gx exists and it can be separated. Note that this can be only separated if both exist. Now, the problem now here is that one exists, one does not exist. What happened to the combination? Will it be always does not exist or sometimes exists? With this theorem itself, we suppose that the limit of negative cosine 1 over x plus 2 sine 1 over x exists. We can say that this is equal to some value of k. Then we already know that this limit also exists, and therefore we will know that negative cosine 1 over x is actually can be written as negative cosine 1 over x plus 2x sine 1 over x minus 2x sine 1 over x. We assume that this limit exists, and we already know that this limit exists. From the theorem, the sum or the difference will also exist. So what we have right now is, with the assumption the limit exists, then this limit will also exist, and this will be a contradiction because we already know that it does not. With this, we know that this assumption is not correct, and therefore, number 1, the limit of f prime when x goes to 0 does not exist, and this is a correct statement. This is a correct statement. Many people will treat that the limit of f prime when x goes to 0 and this expression as the same meaning. In fact, they are totally different. I'll show you what is the value for this limit. So for second one, the limit fx minus f0 over x when x goes to 0. So we'll copy down. X is not equal to 0, so fx is defined as x squared sine 1 over x. And the value of f0 is equals to 0 over x. So this will be just equals to the limit x sine 1 over x. Again, we have seen this just now, and we know that the value is equals to 0. So with this, we know that, hey, this is correct. Now we go to statement 3. F prime 0 exists. What is the meaning of f prime 0? If f prime 0 exists, then it is defined as the limit fx minus f0 over x minus 0 when x tends to 0. This is the definition of the derivative at x equals to 0. And we already know from the statement 2, this is correct. So it is equal to 0. And since this is equal to some real number, therefore it exists. So the first half of the statement 3, correct. Then it says that this function is not continuous at x equals to 0. Now just recall that what is the condition for a function continuous at a particular point? Yeah, 3 conditions. So let me write it down. Let's say if g continuous at x equals to a, then we need 3 conditions. The first condition, the limit of gx when x tends to a exists. The limit must exist, and ga is well defined. And thirdly, this limit must be equal to ga. That's the definition for g to be continuous at x equals to a. Now this g here is equal to f prime. So we will ask this question. Is the limit of f prime when x go to 0 exist? No, it is not from the first statement. And since the first condition is not satisfied, then we will say that f prime is not continuous at x equals to 0. And this means that the statement 3 is also correct. With this, all the first, second, and third statement are all correct. With this particular example, I hope that it's clear to see that these two expressions are not the same thing. They are totally different. So this is the end of today's lesson. Hope you learned something today, and I'll see you again next time. Bye bye.